Hello, my name is Mario. Welcome to another software architecture and Go video. In today's episode, I'm sharing with you the choreography pattern. So what is the choreography pattern? In his book, Building Event Driven Microservices by Bellemare, he describes this pattern as the one where microservices react to the input events as they arrive, without blocking or waiting, in a manner fully independent from any upstream producers or subsequent downstream consumers. The name comes from the real-life dance performance where each dancer knows their own role and performs independently without being explicitly told what to do when dancing. Therefore, the producer of those events is isolated from the consumers receiving the events. What are some of the pros of using choreography? It allows for loosely coupled systems to interact with each other. This means consumers can come and go without any disruption of the upstream workflow. Another pro is that producer business logic is fully isolated from the downstream consumers. What are some of the cons of using choreography? It could be hard to debug in cases where the workflow is complex. Another one is consumers may not need all sent events, making the consumers use resources they don't need. As usual, the link to the code is in the description of this video, so feel free to check it out. I want to be really honest with you, what I'm going to be showing you is just for educational purposes. I don't really recommend it for using it or outside of learning how the choreography pattern works. In cases where you were actually using or planning to use this in the real world, you will be using something like maybe Apache Kafka or Amazon Kinesis, just to mention a few examples. A distributed message bus, so to speak, which will be the one in charge of handling the events, the producers, the consumers, concurrency, and all of that fun stuff. So let me show you this code. Like I said, is in the description. The important bit that I want to show you first is the choreographer type that I implemented is actually right here. This choreographer type will be handling two things that I want to demonstrate. One will be the subscription and publishing of events, and a way for the subscribers to communicate back so they can demonstrate that we are receiving the events or they are receiving the events and also doing something with those values. So this type, like I said, it has two different important conventions that are typically when you're working with mutexes, and one of them will be the usage of the sync, which is right here. The mutex is next to the variable that is going to be protecting in those cases. If you want, the other example will be the one that I have right here. Like I told you before, one is for the subscribers and producer, from the producer itself for sending messages, and the other one is just for adding and updating a variable. Let's jump into the actual implementations of this method. In this case, let's start with subscribe. Subscribe here uses this important thing that allows you to block or lock or protect the variable that you want to, in this case, in the section of the method, to be only used concurrently by one Go routine at the time. So that's why if you notice right here, compared to the one that we have below, one of them is using lock and the other one is using rlock. The biggest difference is that in this case, I'm actually modifying the value. If you notice right here, this channels slice, I'm modifying it. On the other side, if you notice, I'm only sending a message using the channels for sending a message to them. So with that being said, what does this method do? I think it's pretty straightforward. It receives no arguments and it returns a channel. And like I said, it updates the values right here. If we look at the publish, you will notice that it's a bit similar, and it uses the things I told you before, a read lock and a read unlock, and it loops through all of the channels that are meant to represent subscribers, and it sends a message. The other important method that we need to look at it's the one used for closing. And what will close is going to be doing is literally close all the open channels that are representing the subscribers. And for doing that, you just have to loop through all of them, close, and then finally just assign the channels to nil to indicate that we don't have any more in case if the user calls publish again. Okay, this is the important bit that we have to understand about this type in particular. Now the other two events that the other two methods that I want to show you will be the ones that I write here, which are the ones that I told you are used for updating the value that we're going to be updating in the routines that we're going to be implementing in a moment. So this one adds a value, and similar to what I told you a while ago, it's locking using the lock instead of using the r_unlock. But if we compare it to the other one, you will notice that it's using r_unlock, which is a similar situation. Again, you will see what I mean when we implement all of this. All right, let's jump into actual implementation of this code, and we'll tell you step by step what this is supposed to be doing, okay? Let's see. So if we jump at main and we start using the type, we just have to create, let's leave choreographer, let's call it O. Well, that's not a good name. C. And then we want to do something like publish, which is a method that we want to be using and sending a message. We call it message. We want to close to indicate everything is completed. And then we have to use that actually and implement consumers of those events. For doing that, I'm going to be using another type called wait group. Let's call it WG. And the idea of this is that we're going to be using it for launching Go routines, waiting until those Go routines are launched, and then publishing the message to avoid any race condition and issues with the channels. So for doing that, we're going to be defining this wait group. We call it subs to indicate the subscribers. So we just do a for, and let's do just 3 times. So 0, less than 3, I++. We wait, again, that's what I was trying to say. We wait until all of them are launched. We add here the value that we need, which will in this case will be 1, because for each one of the loops we are creating, or we are going to be creating a new Go routine. Next, we create the Go routine that is going to be consuming all of that fun stuff. We're going to be calling the choreographer, and we're going to be calling subscribe. So the subscribe method will return the channel that we're going to be consuming. Now, if you remember in one of my videos, in order to consume, you can use this directive and read the channel until it's closed using the for keyword. So in this case, I'm going to be do a message range channel, and we're going to be only printing f or printing fln the message, and I want to also print the value of I. One important thing with Go routines inside for loops is that you need to pass in that value explicitly or create a new variable scope to the section where you're using that variable. So in this case, what I'm going to be doing, instead of doing that, we're going to be changing this function to receive a value, an int64, which will be the value that we're receiving right here. And we're going to be passing in an int64, which is the value in the for loop. I'm going to pass it down right here, so it maps to the receive value that is coming from the loop. You will see that in a moment. So we just added 1 to make it different, and instead of using I, we use val. So what this is going to be doing is going to be opening 3 Go routines. Each Go routine is going to be subscribing to the choreographer, and it's going to be printing out messages as soon as they are received from the channel in this case. So if we run this, it actually, before we do this, in order to indicate that we are launched already, we need to call subs done. This way we can tell the wait group that we are finished in this case, and you can launch what we were expecting to launch. So if you run this code, you will notice that nothing is actually happening. So why is this not working? Well, typically because the main Go routine is finishing before the new Go routines are actually launched. So what we need to do now to add will be to add yet another wait group. Let's call it WG. And what this wait group is going to be doing is something similar. We're going to be waiting and adding until all Go routines are completed and all of them are finished consuming all the data that we need. So we do something similar. We add the value here. We wait until we move the wait here. And more importantly, when this is closed, therefore the for is going to be finished, we called done. All right. So with that, we created a wait group for the coroutines to launch in the first place, all three, and then another one for waiting for those coroutines to close after we call the close method. Okay, so if we launch this, we should see a message. And there it is. We have the three messages that we are sending through the coroutine. There were triggered because we published the message, and now everything seems to be working. So how can we send that data back? We have to use the other two methods that we have right there. One will be add, and the other one will be value. Let me show you. So now the coroutines are receiving the values from the publisher. Now, if we want to use the other two methods, which are add and value, we just have to update the coroutines to send the data back. For doing that, we just have to modify this call right here. We're going to be calling the C add and passing the value, or rather val, because that's the name of the variable, and then we just go all the way down here after the wait, and we print ln the value. The final value will be C value, and that's just to demonstrate that we're sending the values back to the original publisher. If we run this again, you will notice that now the value is the collection all this, which in this case will be 6. And that's it. This is the choreography pattern in Go. Hopefully this is useful. I'll talk to you next time. Take care. Stay safe. See you.